Good morning, guys. Very good morning, all of you. Prasad, Shruti, Ramesh, Sunita, Sangram, Nagalakshmi, Anjali, Tajamul, Praneeth, Shruti, everyone. Good morning. Very, very good morning, all of you. Very good morning, everyone. How are you all? Everyone, how are you? Right. So, all of you had your tea, coffee, hot water, juice, everything? Breakfast? Tea, coffee, hot water, juice, breakfast, everything is over or nothing is over, all of you? No? Nothing is over? Right. Okay. Right. Akash, good morning. Right. Right. Very good morning, everyone. Right. So here, what we were discussing in yesterday's class, if you just remember, all of you, yesterday we were discussing about this. What you can say that reinforcement we have to start now. Yeah, Babita, Atul, Hasim, Aditya, Prashant. Good morning, everyone. Very, very good morning, all of you. Right. So we have to start discussion of yes, I am good, Vishal, how are you? Right. So this quick concepts and PYQs of which one? RCC materials and specifications part 4 we are discussing, right? Yes, right. It is not related to this full length course. Here you can do it, no problem, right? Akash कर सकते, right? हिंदी मैं भी बोल सकता हूँ बट ओके कम यूज करता हिंदी मैंने ओके विशाल या बबलू okay full length RCC this is not related to that, right? Instead of doing this full length you can do it, right? Yes, right, absolutely right. Shravan, Supriya, good morning everyone. Right, very good morning everyone. Right now here we'll be continuing our discussions, right? All of you, welcome to Unacademy. Let's crack it, right? Everyone is ready to crack? Are you all guys ready to crack? Be ready to crack, everyone, right? Be ready to crack, all of you. Right now here this is my profile. How many of you are following my profile in Unacademy? If not following, you start following my profile. Yeah, Amar Raja, Deepan Kumar, good morning, right? From YouTube, right? Another YouTube channel. Okay, right. So what is the referral code you have to use, everyone? RP Civil is the referral code you have to use, everyone, right? Whenever you are subscribing to this lesson iconic courses, okay? Right now, so these are all SSC JE and State AE toppers from 2022. So if you want your name to be present in this slide next year, so you work hard and work smart and get cracking, right? Everything. So now Independence Day offer is started, all of you, right? SSC JE State AE course now in English. So you will be getting which one? This 20% off with the 4 months extension, right? So July 31st, right? You will be getting which one? This so these AE batches, English batches are started on this July 31st. So now 100% English content will be there. So 20 years of PYQ solving will be there. And also this offer is valid up to which one? This August 12, right? This offer is valid up to which one? This August 12, all of you, right? So don't miss this offer. So 12 plus 2 months, this is the fee. 24 plus 4 months, right? This is the fee you are having, right? So don't miss this, everyone, right? Inform to all your friends, juniors and everybody, right? Those who are willing to go for this, you can say, okay? Now, so which one I have started? Surveying is started by me at 5:30 p.m. in this Samarth batch, right? So Samarth batch, first batch is started, okay? So don't miss this, right? If you are making further late, you are moving further away from your which one? This is selection in the state AE examination and SSC JE examination, okay? Right. So this is these are the details of your batch, you can say, right? And these are all the subjects taken by myself and these are all the subjects taken by KP sir, okay? Now, so you are all having idea about this, what are the major changes in this SSC JE examination, right? So Airport Authority of India, so this is the junior executive posts are there, this many posts. Have you all applied? If not applied, you start applying everyone now onwards, right? So this is the recorded batch you are having further, right? So plus course we have started, complete course on the surveying at 5:30 p.m. to 7:30 p.m. going on, and this is a free course, right? Free course on this quick concepts and PYQs of this RCC and PSC. Okay, so we'll be doing in the plus course, we'll be doing, and in the free course also we'll be doing few things, right? So if not applied, you start applying. Okay, you start applying from now onwards. Supriya Lakshmi, good morning. So fourth lecture, quick concepts and PYQs of RCC, materials and the specifications, part 4, right? Right, now coming to this fundamentals of this RCC design, materials and specifications only. So here, so yesterday we have seen this part, right? Yes or no? Mild steel and this medium tensile steel will be conforming to which code? IS 432 part 1. Okay, high yield strength deformed bars, right? HYSD bars are conforming to which code? You can say IS 1786, right? Hard drawn steel wire fabric conforming to which one? This IS 1566. Sir, generally in our beams, columns, slabs, everywhere we'll be using this rods only, no, bars only, no. But where this steel wire fabric comes into picture, sir? Have you seen anywhere this steel wire fabric, all of you? Have you seen this wire fabric anywhere, all of you, or not seen? Steel wire fabric, have you seen? Right, where? What is the example? Tell me where you have find this wire fabric, wire mesh you will be finding generally, where it is. Have you observed this culvert pipes? They will be making these pipes now. Have you observed anyone? Have you observed anyone? These are the pipes you are having, yes or no? These are the pipes you are having, yes or no? Have you observed anyone? So here these pipes are made up of which one? So first they will be doing which one, all of you? First they will be creating this mesh, if you just observe, right? It's not. So this kind of mesh they will be preparing, right? So this kind of this mesh they will be preparing, and after preparing this kind of this mesh with the wires, so what they will do, if you just observe, they will be making into this circular shape. After making this into this circular shape, right, what happens, you can say, after making this into this circular shape, right, they will be casting the concrete over that, right? As now, have you seen this? So this is wire mesh you are using, is that? So this is that wire mesh you are using, right? As now, so like that we can use, right? Very small thin structures we can use this wire mesh also, right? And it should be free from which one? This mill scales, right? Shall be free from loose mill scales, right? What is the meaning of this mill scale, you can say, everyone? What is the meaning of this mill scale, everyone? Mill scale is nothing but your, so the residues left from the mill, right? The residues left from the mill, so we should have them or we should not have them whenever you are using the reinforcement, right? We should not have them, na? Whenever the reinforcement is there, we should not have them in our steel, right? So whenever you are having them, right, what is the disadvantage? Can you able to expect a full bonding with the concrete then, or it may not be able to expect full bonding with the concrete, right? In that case, full bonding may not be expected, na? Yes or no? Because this is your steel, on this you are having that scaling material. Is it possible to ensure 100% bonding with the concrete in that case? It is impossible, na? The properties of this steel also may be changing definitely or not? The properties of this steel also may be changing definitely, right? So then in that case, that scales, right, scales created from this mill should be present or they should not be present, if you just observe. They should never be present, yes or no? They should never be present, right? They will create a damage or they will help us, they will automatically create any damage, yes no? This is SSC JE state AE JE PYQs, okay, not GATE PYQs. Gopi, good morning. So like that. And lose rust, right? If rust is present, it is advantages or it is disadvantages, you can say. Whenever loose rust is present, right, what this rust will do? It will create, it will extend further rusting, na? Is or no? Suppose if at all there is any loose rust present here, what happens, you can say, So this will be further extending onto the other parts of this reinforcement bars or not? So then that is advantages or that is disadvantages? Absolutely. That is advantages or that is disadvantages? Absolutely, you can say, right? That is absolutely disadvantages na. So that is absolutely disadvantages, you can say, right? So this rusting also should not be present, or at everyone, this rusting also should not be present, you can say, everyone, right? And also paints, oils, why these coats of paints should not be present? If these coats of paints are present, right, these paints will be in which condition? They will create a slipping of this reinforcement in the concrete or not? These paints, oils and mud, they will create full bonding, or they will cause a slipping of this, you can say. They will cause a slipping of this now. Absolutely, they will cause a slipping of this if you just observe. They will cause a slipping of this if you just observe, right? Yes, now. So now here what is that, you can say? Mild steel is nothing but your which grade if you just observe? That is your Fe 250 grade. And high yield strength deformed bars are nothing but which grades if you just observe? Fe 415 comma this Fe 500 now, and Fe 415 comma Fe 500, right? Hard drawn steel Y fabric means they will be like this, will be having, right? Structural steel conforming to this grade A. So what is the meaning of this structural steel? Which one is the main member? Steel is the main member na. Whenever it is mentioned as the structural steel, means steel is the main member or not, everyone? Yes, steel is the main member, absolutely, right? So if you are taking it as a reinforced concrete, means concrete is the main member, steel is the secondary member, which is just helping to improve which will just help to improve which one? The properties of this concrete, that's it, okay? But structural steel is nothing but your steel itself will be the main member na, isn't it? But where we will be using it in our RCC structures if you just observe? Do you have any idea, all of you? So here if you just observe, whenever we are having this slabs, right, composite structures will be studying now. So whenever these composite structures, right, what is the meaning of this composite structures? So here steel will be one of the main member and concrete is also main member, you can say, right? Steel is not the secondary member. So what we'll do here, we'll be constructing this, right? So this beam will be constructing with which one? This beam, instead of this concrete beam, will be taking it as this steel beam. So now tell me, in place of this beam, you are having this steel member only na? So steel is also a main member or not? Absolutely, steel is also a main member, you can say. And for the slab, you are using the concrete only na? Concrete is a main member. And this top flange of this steel beam will be used as which one? It will be used as the reinforcement there, right, like that. Is it clear? Omar, Ashwin, Ashik, good morning, right? Is it clear, everyone, that one? So where we are using this structural steel if you just observe, where we are using that structural steel if you just observe, is it clear, all of you? Is not? So but this A comma B are which one? This A comma B mentioned are which one? These two are this is B not H, okay? This A comma B mentioned are which one? This is reinforcements na. Those are the main members or those are not the main members, right? Those are not the main members, right? Those are the reinforcements, you can say, right? Is not? So clear, everyone, this one? Is this clear, all of you, everyone? Is this clear, everyone? Right? So shall I move to the next? So what we need to do? We need to use that sand blasting to clean the reinforcement, right? How can you clean the reinforcement, right? If at all there is any rusting kind of these elements are present, we have to use this sand blasting, right? अरे कौन सा लैंग्वेज समझ में नहीं आ रहा है क्या? कौन सा लैंग्वेज? विच लैंग्वेज आई एम यूजिंग? अक्षय शर्मा इंग्लिश यूज कर रहा है ना? सुनो, इंग्लिश लैंग्वेज यूज कर रहे हैं मैंने, ओके? इंग्लिश लैंग्वेज यूज कर रहे हैं और कभी कभी भी ये हर एक क्लास में ऐसा बोल रहे हैं। आपको इंग्लिश नहीं समझ में आता है क्या? राइट, अंग्रेजी बोल रहा है मैंने, ओके, राइट। Sand blasting we have to use, right? Sand blasting we have to use for which purpose, you can say? To clean the reinforcement, right? So parvalla, continue. Okay, right. So here whenever that reinforcement is having rusting, okay, so reinforcement के ऊपर कुछ rusting है तो पेंट है तो राइट, ऑयल्स है तो, मड है तो राइट, क्लीन करना ही पड़ेगा ना डेफिनेटली. So we have to clean whatever it is present or not, paints, oils, mud, etc. So we have to clean it, right? How can we clean it? कैसा clean करना है? Sand blasting use करके clean करना है, right? So we have to use the sand blasting for cleaning it definitely, right? Yes, now. So shall I move on to the next? Now here if you just observe. Yeah, I'll explain that, right? I'll explain that, right? Don't worry. I'll explain that sand blasting, right? Yeah. Just I said we have to use sand blasting. What is that sand blasting? I'll explain now here. Okay? Don't worry. Don't worry. You have to have little bit patience. Okay? So this is before using that sand blasting, right? This is before using the sand blasting. It is like this, right? How it is? Tell me. This reinforcement is in a good condition or not in a good condition? Tell me. ये गुड कंडीशन में है क्या नहीं, अच्छा वाला कंडीशन में है क्या नहीं. दिस इज नॉट इन द गुड कंडीशन ना, ऐसा नो. सो व्हाट इज देयर ऑन द सरफेस? फुल्ली रस्टिंग विल बी देयर ऑन द सरफेस ना. फुल्ली रस्टिंग विल बी देयर ऑन द सरफेस और नॉट ऑल ऑफ यू? हेलो, व्हाई नोबडी इज रिस्पोंडिंग? इट इज इन गुड कंडीशन और पुअर कंडीशन? It is in poor condition. Why it is in poor condition? Why it is in poor condition? Because you are having full of rusting on the surface now. Because we are having full of rusting on the surface, right? Before we use sand blasting, right? After we use sand blasting now, so we'll be getting like this, right? We'll be getting like this, right? It is now in a good condition now. Entire rusting will be eliminated now. Here also if we just observe these bolts and the nuts also, this is in a rust condition before we use the sand blasting, and after we apply this sand blasting, right, it becomes like this, right? It becomes like this. Okay, so what is that sand blasting? If you just observe is, right, so what is that sand blasting? If you just observe is compressed air. Okay, so what we'll be doing is compressed air. So whenever we are sending a compressed air means it will be under a lot of pressure or it will not be under pressure? Tell me. Compressed air will be under lot of pressure ना. So कौन सा वाला examples हम observe कर सकते हैं compressed air के बारे में? LPG gas cylinder, is ना? So that is the compressed air only ना, ऐसा no? That is the compressed gas or this air only, no? ऐसा no? So lot of pressure will be there whenever you are opening it, right? It will come out with a lot of pressure. Na? In most of the movies you might have observed that, right? Hero when there is a fight between the hero and villain, so what happens? So that gas cylinder will blast and that gas will come with a lot of pressure. Have you observed that? Is not? So that is a compressed air, right? Very much compressed air means it will be sent with the pressure, right? Plus abrasure, right? What is that? Yeah, abrasive material, right? Abrasive material क्या है? What is the meaning of this abrasive material? If you just observe, what is the meaning of this abrasive material? Compressed air plus this abrasive material. So plus which one? This is a rusted steel reinforcement, right? Rusted reinforcement or steel elements. So whenever you are having these elements, if you just observe, this will be resulting in which one? This that process is called as your sand blasting. Why we are calling it as a sand blasting is because this abrasive material which we are using is a sand. Okay, have you observed? Whenever anything happens, right, just to clean the metal surfaces, wooden surfaces, so these people will be using the sandpaper, and with the help of this sandpaper, right, what will be doing? They will be just rubbing on this surface so that it will become clean enough. Have you observed that? What that sandpaper sand is doing? It will be abrasing na. What is the meaning of this abrasing? Rubbing na. It is just rubbing, right? Abrasive material means the material used for rubbing. It will be rubbing the surface so that the top unnecessary material will be removed or not. The unnecessary material on the top will be removed, you can say, is now. So similarly here also, so you will be sending the air with a lot of pressure, and that too in that with the air, what is that you are having? Sand is there, right? So you are sending the air already. So this is your reinforcement bars, right? These are your reinforcement bars or whatever it is. So steel materials you are having. So they are placed in a container. Okay, they are placed in a container. Inside that sand is also there, and you are sending the air. You are sending the compressed air with a lot of pressure, and what happens? So they will be moving here and there, right? Like that they will be moving. Na? Whenever they are moving here and there like this, along with that, that sand will come with a pressure and it will hit these parts surface. Na? If you are doing this process continuously for 1 hour or 2 hours, what happens? The surface of this steel will get cleared automatically. Na? The surface of this steel will get cleaned automatically, or not everyone? With force you are sending the air and sand particles, the sand particles will rub the surface and they will clean it, obviously, or not? That is called as your sand blasting, right? Is it clear, everyone? The meaning of this sand blasting, all of you? The meaning of this sand blasting is clear, all of you? Everyone? It's not that sand will be used as an abrasive material here, right? So those who are willing to enroll for this batch, right, Samarth batch, you just enroll for this batch, right? If you did not enroll previously, you just enroll now. Okay, Sunita, you send something. Yeah, that is the sandpaper. Yes. So here what we are doing, directly we are rubbing na? Using this sandpaper, right? What you can say, using this sandpaper will be directly rubbing the surface na? But if you rub directly, how much time it will take? Lot of time. But if you are just keeping inside the container and apply force, it will be completed within lesser time na? Like that. No, here. So along with the reinforcement, right, what is another one is there? Along with the reinforcements, TMT bars are also there as a reinforcement na? Is that no? So mild steel will be there. We'll be having which one? That a reinforcement bars, right? Which reinforcement bars you are having? Mild steel will be there. Along with that mild steel, HYSD bars are there. Along with this HYSD bars, what else you will be having? Tell me. IS 486 2000 has not defined anything about, not discussed anything about that, but still in the field we are using it, right? What is another kind of this material we are using for reinforcement? Everyone? Anyone? What is another kind of material we are using for reinforcement? All of you, if you just observe. It is a TMT bars we are using. Is that no? What is it? TMT bars we are using, if you just observe, right? Okay. TMT bars we are using, right? How these TMT bars are there? So whenever it is a mild steel, na, they will be plain bars like this. HYSD bars, na, right? These are HYSD bars only, no? Is that no? These are HYSD bars only, right? So these are not plain bars. So the bars will be like this. Along with that, these deformations will be present on this, right? Thermomechanically treated. Okay, what is the TMT, everyone? What is the TNT? Thermomechanically treated bars, right? Thermomechanically treated bars, you can say, right? So here, generally, whenever you are using this mild steel, it is very much a ductile material, right? What is the advantage of this being ductility? What is the advantage of being ductile? Because whenever your member is subjected to failure, na, it will fail suddenly, or lot of deformations will come before failure. Lot of deformations will come before failure. Na? So whenever lot of deformations will come before failure, we can identify that it is going to fail in near future. Na? So that is advantage of having ductility. But HYSD bars, higher strength. So whenever that higher strength is there, carbon content is increased, higher strength will come. So whenever that higher strength will come, ductility, carbon content increases. As the carbon content increases, to increase the strength, ductility decreases. So whenever strength increased, advantage only for HYSD bars, but a ductility decrease. So whenever ductility decreases, is the advantages or it is disadvantages, you can say? It is the disadvantages now. So then what we need to have? So both ductile materials we should have, right? Both ductile materials, ductile nature we should have. At the same time, we should have higher strength also, right? How both are possible? By means of this TMT bars, it is possible, right? So why? If you just observe, at the center you will be having which one? This one soft material, okay? At the center you will be having some soft material, and there will be one transition material you are having, right, which is neither too soft nor too hard. And after that you will be having which one? This is a top layer. What is that top layer? You can say that a top layer will be which one, everyone? That is your very much hard and high strength layer. So that what will happen? So this hard layer will be taking care of what? That hard layer will be taking care of which one, everyone? That hard layer will be taking care of this higher strength. Na? That hard layer will be taking care of this higher strength, and you will be having which one? This is soft layer inside, right? That soft layer will be taking care of which one? This ductility. So now with the help of this TMT bars, both ductility and strength properties are achieved. Na? So compared to this mild steel and this HYSD bars, this TMT will be more advantageous or not, everyone? Yes, no? Is it clear? Yes or no, all of you? Is it clear, all of you? Right, once clear, once these are all noted, tell me. We'll just try to move on to the next. If anybody is noting, you just tell me. Once noted, I'll move. Clear, everyone? The meaning of this is sandblasting. So we are sending a compressed air into the container having this abrasive material like sand, and along with that rusted reinforcement or steel elements. Right. Once clear, note down. Once noted, tell me, everyone. We'll try to move on to the next. So generally, mild steel is having higher ductility, na? Yes or no? Mild steel is having higher ductility, right? Mild steel is having this higher ductility. Mild steel is having higher ductility. That is advantage, right? What is advantage? Because whenever you are having this ductility, it will deform by larger extent before failure. So whenever you are placing this reinforcement mild steel bar in the beam, na, first it will deform like this. Then you can understand that this bar is going to fail. So it is better we have to repair it, or it is better we have to which one? This construct a new beam, right? Yes, now strength is lesser. So advantage is ductility, disadvantage is what? A lesser strength. Okay, and HYSD bar, if you just observe, strength is higher but ductility is lesser. Whenever ductility is lesser, can we get a warning before failure, or it may suddenly break? It may break suddenly, na? Then in that case, right, what we need to do? So mild steel is which one? Mild steel is having one advantage, ductility, and HYSD bar is having one advantage, that is strength. So one is having one advantage, one disadvantage, these two are having, but TMT is having both advantages, right? So mild steel advantage, ductility it will be having because of this soft material inside the core. That core or this central material will be soft material. It will impart ductility to the member. HYSD bars, right? This right. After soft core, right, what happens? That a transitional material is there, right? It is neither too soft nor too hard, it is intermediate, right? Because suddenly if you are changing from this soft condition to hard condition, there may be a non-cooperation between the hard layer and this soft layer, na? So that's why that transition layer will be providing, right? So which is acting like a coordinator in between this hard layer and this soft layer. And that hard layer will be resulting in which one? This is strength, na? That a hard layer will be resulting in which one? This is a higher strength, you can say. Is that clear now, Anjali? What is the advantage of this TMT bars, right? What, how this TMT bars are developed, why they are developed? Clear? Right. No. Yeah, generally, mild steel Fe 250 grade. So HYSD bars 415 and 500. And TMT bars generally we are having which grade? 550 grade starting onwards, right? 600, 700 grade also there, but 550 grade is the starting grade. Okay, you are having. No. So now if you just observe it, what is that you can say regarding this steel? The modulus of elasticity ES will be equal to 200 kilonewton per millimeter square, right? So what is that 200 kilonewton per millimeter square? If you just observe, this is nothing but your 2 into 10 power 5 MPa. What is that MPa? Megapascals is nothing but your 1 Newton per millimeter square or not? Megapascals is nothing but your 1 Newton per millimeter square, right? So 2 into 10 power 5 Newton per millimeter square, right? So this is applicable for which grades? This is applicable for what? This is applicable for this all, right? Mild steel it is applicable, HYSD bars it will be applicable, as well as for this TMT bars also it will be applicable now. Mild steel, HYSD as well as this TMT, right? For all the bars it is applicable, right? Yes, now for all the bars it will be applicable, you can say. Yes, now so this generally that mild steel is nothing but your Fe250 grade. HYSD bars, right? What is it? You can say Fe415, 500 grade. And what is it? TMT, you can say that Fe550 generally we are having, right? At present it is in the use. Which grade it is in the use? 550. Okay, right, like that. Now the characteristic yield strength of different steels shall be assumed as minimum yield stress or 0.2% of this proof stress specified in a relevant Indian standard, right? So what is that minimum yield stress? Minimum yield stress is nothing but your lower yield point, you know. In your stress strain curve of this yield, stress strain curve of this mild steel, do you remember that strength of materials? Lower yield point will be taken as the yield stress of the material. Okay, so if you just observe for various steels, what is that we have to take? For a mild steel we have to take it like this. So whenever you are having this stress strain curve in this manner, that y-axis is your stress, x-axis is your strain, you guys, right? Shubham, good morning. X-axis is your strain, right? So now here how it will be, if you just observe it will be in this manner. Now, so do you remember these points, everyone? So this is your upper yield point, no? Arre Baba. This is your upper yield point or not, right? That is your upper yield point, right? This is your lower yield point, na? This is your which one? This is a lower yield point, you can say. Arre, it is getting stuck, I don't know. This is lower yield point, right? So this is which one? This elastic limit, na? So no, this is your elastic limit. This is your proportionality limit, yes, na? So now which one will be taken as your yield stress for this mild steel? If you just observe, this is a minimum yield value, na? So this is taken as your yield stress, right? Fi. So characteristic yield strength rate means what is the symbol we are giving for this characteristic yield strength, all of you? What is the symbol we are giving for this characteristic yield strength? That is Fy is the symbol we are giving for this characteristic yield strength, na? Fy is the symbol we are giving for this, right? So this will be taken as Fy for which one? This is for this mild steel only, no? Mild steel, right? So Fy, or you can also give the symbol sigma y, right? Which symbol you are habituated with, everyone, for yield stress? Fy symbol or sigma y symbol, everyone? Fy symbol or this sigma y symbol? Any symbol is okay, right? Either it is Fy symbol or it is which one? Sigma y symbol, right? Any symbol is okay, you can say, yes, na? Now suppose if it is other than this mild steel, other than mild steel, that the stress strain diagram will be like this, right? Other than mild steel, right? What is it you can say? The stress strain diagram will be like this, if you just observe, right? Yes, na? This is stress, this is strain. How the diagram will be, if you just observe, the diagram will be like this. Now can you able to identify it? Can you able to identify these yield points? Is there any defined yield points you are having, or there are no defined yield points available? If you just observe, right? There will not be any yield points available. Can you able to identify that? Whenever there is a change in the graph suddenly, we can say that that is a yield stress point, right? Yield point stress. But is there any sudden change in that yield stress point, or there is no sudden change in that yield stress point? You can say there is no sudden change in that yield stress. There is no sudden change in the graph. Whenever there is no sudden change in the graph, right? What is that you can say? Yeah, can you able to define the yield stress, right? Is there any condition to identify that? Can you able to identify sudden changes in the graph? No sudden changes in the graph, right? Then what happens if you just observe? Then what we need to do? So here it is observed that, right? It is observed that all materials will be subjected to yielding at which one? All materials will be subjected to yielding at which one? 0.2 percentage strain, right? In strength of materials, I have explained that in detailed manner. So, but here it is not that much required. In SM, it is required. Okay. So, what happens whenever you are shifting from this upper yield point to this lower yield point? That sudden decrease in the strength will happen, right? Permanent yielding will be starting there. Okay. Permanent yielding will be starting there, right? So, that permanent yielding will occur at a 0.2 percentage strain in the material, right? Okay. Like that. What is the reason and everything? So in strength of materials we'll know, right? Not here. So then what we'll do corresponding to that, right? Corresponding to that we will take which one? So we will take which one? This is 0.2 percentage strain you take it, right? 0.2 percentage strain you take it. And how to draw this line? Exactly parallel to the initial straight line you have to draw, right? So how you have to draw the line? Exactly parallel to the initial straight line you have to draw that. Once you are drawing a parallel to the initial straight line, so then it will be intersecting with the curve at some location. So corresponding to that stress will be taken as your Fy or this sigma y. So that is called as your yield stress, or it is also called as your proof stress, right? Why you are calling it as a proof stress? Because we are proving it, na? Are we identifying directly, or we are proving, or we are deriving it from various conditions? We are deriving or proving it from various conditions now. So that's why this is called as your proof stress, right? Is that clear, everyone? These points? Young's modulus is how much, and how to get this? Young's modulus is how much, and yield stress how to get for various types of these steels. Okay. So those values given, Fu 250 means that 250 will be representing the yield strength, or this that is representing the ultimate strength. That 250 will be representing the yield strength only, no? Fe 415 means that is representing that yield strength only, no? Fe Farad also that is representing the yield strength only, no? Fe 550 also that is representing the yield strength only. Yeah, I'll be closing the session. I don't know. From 20 minutes onwards, I'm feeling a lot of stomach pain is happening. I don't know why. I'll close the session. I can't bear it. Sorry guys, I'll continue in the tomorrow. We'll continue day after tomorrow. Tomorrow class will not be there. I could not bear it. I don't know whether 10 AM class also will be there or not. I'll inform. Okay, don't worry. Sorry guys. So much paining. I could not bear it. I am controlling, but it is not getting controlled.